Hello students, today we learn about independent events and probability calculation. Now, first question that arises is, what are independent events? If I have two events A and B, happening of A does not depend upon occurrence of B. It is called an independent event. A can happen even without B happening, and B can happen without A happening. To understand this, we'll take an example. Tossing of a coin. Sample space for this is head and tail. When you toss a coin, you can either get head or tail. Another event is throwing a dice. When you throw a dice, the possible outcomes are 1, 2, 3, 4, 5 and 6. Because a dice has 6 faces. It's a cube. Coin has 2 faces. You can get either head or tail. Now, what is the possibility of getting a head or a tail? It is 1 by 2. Now, what is the possibility of getting 1? It is 1 by 6. The possibility is same with respect to other numbers. Possibility of getting 2 is same as probability of getting 3 or 4 or 5. Now we know the probabilities of both the events. Now, if I want to find out whether these events are independent or not, I calculate probability of getting head and 6. Say, for this I have to write a new sample space. I toss a coin and I throw a dice. So the sample space will look like this: head and 1, head and 2, head and 3, head and 4, head and 5, head and 6, and we can also have tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, tail and 6. The size of the sample space is 12. Now, what is the probability of getting a head and 6? That is this. It is 1 by 12. Now, we will calculate individual probabilities. What is the probability of getting a head? That is half. What is the probability of getting 6? That is 1 by 6. If I take the product of these two probabilities, I get 1 by 2 into 1 by 6, that is 1 by 12. That is nothing but this. So, probability of head intersection 6 is equal to probability of getting head into probability of getting 6. Therefore, these two events are independent events. Now we'll find out what are dependent events. If I have probability of A happening to be 3 by 4 and probability of B happening to be 1 by 4 and probability of A and B happening to be 5 by 6, say. Now we take the product. Probability of A into probability of B, that is 3 by 4 into 1 by 4, that is 3 by 16, which is not equal to probability of B intersection A. Now, so we write probability of A intersection B is not equal to product of probability of A happening and probability of B happening. So these are dependent events. Now we'll talk about mutually exclusive events. We say A and B are mutually exclusive events when A happens, B does not happen. When B happens, A does not happen. Example is tossing of a coin. You can either get head or tail, never both. Rolling of a dice. You can get one number at a time. You can either get 1 or 2 or 3 or 4 or 5 or 6, but never you can get two numbers at the same time. When you have pack of cards, probability of picking one card at a time. When you pick a card, you can pick either a black card or a red card. This is all about mutually exclusive events. Thank you.